Okay, we're going to move on to relations, function, and function notation. A relation is a set of ordered pairs that can be represented as a table, graph, or a map. The inverse of any relation is obtained by switching the coordinates in each ordered pair. So, for example, if I give you the point 4, -5, the inverse to that point would be -5, 4. All you're going to do is take the given ordered pair x, y, and write it in y, x form. Not opposite in terms of positive, negative, just switching your x's and y. Relations in each element of the domain is paired with exactly one element in the range is called a function. I think last year with Mrs. Cargill, you might have spoke about that. I need to turn my paper. We're going to start with ordered pairs. I'm going to give you a set of ordered pairs. They're written in the curly brackets. Each ordered pair is separated from the next with the comma. So as I state these ordered pairs, it doesn't really matter the order. Just fill in the relation here. So I'm going to give you the pair 4, 3, -5, 4, 3, -2, 2, 4, 5, -5, 3, 0. This is considered a set of ordered pairs. Next to that, we're going to talk about input-output tables. Here is one way to write that. Here is another way. The input is always the x's. The output is always the y. When you're working with a vertical table like this example here, x will be found on the left, y's will be found on the right. When you're working with a horizontal table, x's are found on the top row, y's on the bottom. So when I go here, that's my x and my y. Here will be my x and my y. We mentioned the words domain and range in our definitions. X's are your domains. Y's will be your ranges. Domains will tell you right and left. Ranges tell you up and down. So again, domains and ranges. Take a moment and place these ordered pairs inside this table. So I will just rewrite. Typically, when we're making tables, we like the x's to be in numerical order. So when I make my horizontal table, I will now put my x's in numerical order with the smallest one first. So that would be -5, 4. Then I would have 2, 4. 3, 0. Oh, I have another 3, so I have 3, -2. I then have 4, 3, and 5, -5. So these are relations. Now we read in the definition of a function that exactly one domain is paired with exactly one range. When I look at this table, even though they're the same, I am noticing my domains of x here, where there are 3, are paired with 2 different ranges. 3 goes with 0 and 3 goes with -2. So this is not a function. For it to be a function, every x would have to go with a different y. All right, moving on. Now we're going to put this on a coordinate graph. Remember, we talked about this the other day, that x's will tell you the left or right. The y's tell you the up and down. The x-coordinate tells you how far left or right. The y tells you up or down. So I'm going to just take the ordered pairs from up here and place them on the graph. All right, so 1, 2, 3, 4. You may pause the video and work ahead if you want. That is how mine looked when we are done. We have mentioned, or hopefully in the past you've heard of the vertical line test. To see if this is a function, will it pass the vertical line test? I would literally put my pen or pencil on the left-hand side of the graph and move left or right. To pass the test, I may only hit one ordered pair at a time. Well, right here in my graph, my ink pen falls on this ordered pair and this one, so it would fail the vertical line test, meaning it is not a function. Mapping. Remember, our inputs are our x's, our outputs are the y's, our inputs are the domain, and the outputs or the y's are the ranges. We are now going to list, without any repeats, the x's from our set of ordered pairs above in numerical order, least to greatest, with no repeats. So I just took that data from my horizontal table. I listed it there. Now I have not written this yet, but I'm going to take my output, my y's, the ranges, list them in numerical order without any repeats. So as I look, I see -5, I see a -2, 0, 3, and a 4. We now will connect the ordered pairs using an arrow. My first ordered pair from that table is the ordered pair -5, 4. So -5, 4. I have the ordered pair 2, 4. So I would draw an arrow from the 2 to the 4. I have 3, 0. Oh, and I have 3, -2. I have 4, 3. And finally, 5, -5. All right, the left shape contains all the inputs, the x's, without repeats, meaning do not write any digit twice. The right side contains all the outputs, the y's, without repeats. An arrow is drawn from each input, x, to the corresponding output, y.